Hello everyone, this is Miss Din's lesson on grade 8 math. This is the fourth video on factoring polynomials. So ready your notes, ready your pens as we go through learning factoring polynomials. But before anything else, I would like to remind you that there are some instances that I will be asking questions. And if it comes, I would like you to pause the video, think over of what could be the answer, and unpause when you're ready to proceed. This time, we are going to focus on factoring sum and difference of two cubes. Are you ready? Before proceeding to our main topic, let's recall on the cube of a number. Now, a cube of a number is the resulting product of a number multiplied to itself twice. For example, 2 multiplied to 2, multiplied again to 2, the answer is 8. Negative 2 multiplied to negative 2, multiplied again to negative 2, the resulting product is negative 8. Notice here, 8 and negative 8 is a cube. So remember, a cube of a positive number is positive, while a cube of a negative number is also negative. Some of the cubes are 27, 64, and so on. Now how about cube roots? This is a number that produces a specified quantity when multiplied by itself twice. Just like what we had a while ago, 8 was a cube, and 2 here, as well as the negative 2's, is what we call the cube root. The cube root of 8 is 2, and the cube root of negative 8 is negative 2. Remember that a cube root of a positive cube is a positive, while the negative cube has a cube root of a negative number. How about cubes and cube roots of variables? Now, the variable is considered a cube if it has an exponent that can be divided by 3. For example, here, we have a multiplied to itself thrice. The answer is a to the power of 3. Notice that the exponent 3 is divisible by 3. And we have another example which has a cube of a to the power of 9. And notice again, 9 is divisible by 3. Now remember, in order to get the cube root of a variable, simply copy the base and divide the exponent by 3. Let's proceed. So how do we factor the sum and difference of two cubes? Or how do we know if the given polynomials are indeed sum and difference of two cubes? Let us observe on the given patterns. There are two patterns here. The first pattern shows the sum of two cubes, and the second pattern shows the difference of two cubes. Now, how did we get this pattern? How were this pattern made? Let's try multiplying the two factors and let us see if the resulting product is indeed a sum of two cubes. So, we will multiply first the first term of the first factor a to each term of the second factor. So we have a times a squared is a cubed. A times negative ab is negative a squared b. A times b squared is positive ab squared. Then let's try multiplying this b to each term of the second factor. We have b times a squared is positive a squared b. B times negative ab is negative a b squared. And b times b squared is positive b cubed. Notice that negative a squared b and a squared b, if added, will become 0. So we can cancel this out. Notice also that ab squared added to negative ab squared is equal to 0. So this is also cancelled. Therefore, the remaining product is a cubed plus b cubed. It's indeed a sum of two cubes. Now how about you try the other factors. Try multiplying them on your own. With this pattern, we are able to get the following steps. First, prepare two sets of parentheses for the two factors, binomial for the first factor and trinomial for the second. Second, get the cube roots of the first and the second term. Then write them as the first factor. Copy the sign, addition, or subtraction according to what is given. Third, use the first factor to get the second factor. The first term is the square of the first term of the first factor. The second term is the product of the first and second term of the first factor. And the third term is the square of the second term of the first factor. We will be using these given examples. First example, we have a cube minus 1. The first term a is a cube and 1 is also a cube. Therefore, the given is the difference of two cubes. Remember that we have to prepare two sets of parentheses. The first one is a binomial and the second one is a trinomial. Let's determine first the cube roots of the first and second term. The cube root of a cube is a to the power of 3 over 3, so that is a to the power of 1 or simply a. The cube root of 1 is simply 1. So therefore, the first term in the first factor is a, and the second term of the first factor is 1. And copy the sign of the given minus. Then, on the second factor, we will be using the first term of the first factor. We have to square a, so the square of a is a squared. Then, the opposite sign, minus, will become positive. Then, we will multiply the two terms for the second term. And a times 1 is simply a. Then lastly, we have to square the third term, and that would be 1 times 1, which is positive 1. And that is our factored form. Second example, let's have m to the power of 6 plus 64. M to the power of 6 as well as 64 are cubes, and the middle sign is plus. So the given is a sum of two cubes. Let us make first the two sets of parentheses. The first set is a binomial and the second set is a trinomial. Now let's get the cube roots of the two terms. The cube root of m to the power of 6 is m to the power of 6 divided by 3 is m squared. The cube root of 64 is 4. So the first term is m squared and the second term is 4. And copy the sign plus. First, we have to square m squared. When we square m squared, that is power of a power. So we will multiply 2 and 2, and that is 4. So this is m to the power of 4. The opposite of plus is minus. Then we multiply m squared as well as 4, and that is 4m squared. Then we square 4. 4 times 4 is positive 16, and that is our factored form. Let's have the last one, a to the power of 6 minus 8c cubed. Both the first and the second terms are cubes, therefore the given is a difference of two cubes. Let's prepare first the two sets of parentheses. This is a binomial and this is a trinomial. Now get the cube roots of the two terms. Cube root of a to the power of 6, that's a to the power of 6 divided by 3, that is a squared. Cube root of 8c cubed is 2 and c. Therefore, the first term of the first factor is a squared. Copy the sign minus, and the second term is 2c. And for the first term here, we have to square a squared. So that is a to the power of 4. Opposite of minus is plus. Then a squared times 2c, that is 2a squared c. Then 2c squared is positive 4c squared. And that is our factored form. Now, did you understand what we have discussed? Let's apply. Which of the following is the factor of the given polynomial e cubed minus 1? You're given two choices. Try it on your own. Pause. Do you have the answer? Yes. It is the quantity of e minus 1 multiplied with the quantity of e cubed plus e plus 1. Which of the following is the factor of the given polynomial? A to the power of 6 b cubed minus 8. You are given two choices again. Try it on your own. Pause. Do you have the answer? Yes. The answer is a squared b minus 2 times the quantity of a to the power of 4 b squared plus 2a squared b plus 4. How about this? I would like you to try it on your own. Pause. Do you have the answer? Yes. The answer is 2 times the quantity of a squared b plus 3 times the quantity of a to the power of 4 b squared minus 3a squared b plus 9. Now, there are three factors. Why do you think so? How did you answer it? Very good. Remember, before using any other methods, check first if there are any common factors, just like what we did on the third question. Then the patterns given can only be used if the binomial is composed of two cubes and it could be addition or subtraction. Thank you so much for learning through with me factoring polynomials. Did you take notes? Did you understand? By the way, there are more examples in this channel. Try it out. Until next time.